Last time we made this sawhorse design in Kumiki, and today, since I really love sawhorses, we'll make another one. So I've had this design in mind to make a sawhorse with two beams on top, sort of forming a narrow split-top workbench, with the stretcher forming a tray. So we'll go ahead and make this design today, and we'll only be using standard 4x and 2x lumber. Start a new Kumiki file and call it Double Sawhorse Workbench. Start by creating a 2-foot by 4-foot footprint. Then place two parallel feet on the inside of the footprint on the 2-foot sides of the footprint. These feet are 4x6 with 6-inch dimension in the z-axis. In the middle of these 2 feet, add 2 posts. The post should be 4x6 with the 4-inch dimension in the same axis as the 4-inch dimension of the feet. Each pair of posts on a foot should be spaced 3 inches apart from each other and centered on the foot. Specifically, the gap between the 2 posts is 3 inches. Finally, join the tops of the double sawhorse with 2 4x8s that sit on top of the 2 posts with the 4-inch dimension in the z-axis and extend beyond the posts by 8 inches on each side. And it's done. And this looks just like what I was asking for. Now, it does look a little bit weird with the feet kind of short. I think the legs are maybe a little bit too tall. I will be adding a stretcher to this in a moment, and I think that will help balance the look. I think this is a great start. And I did do this with the new Fable 5 model, which I am pretty impressed with so far. Now, let's add some joints, and once again we'll be using mortise and tenon joints. Now, this is a new version of Kumiki from the last one, and I've updated the agent instructions a little bit, so I think it's going to do a much better job orienting the tenons correctly on the first try. Please connect the posts with the feet using mortise and tenon joints. The mortises should be through mortises, but the tenons only need to go down by 3 inches. So I've left the instructions a little bit vague on purpose. Let's see if the agent does better this time with the improved instructions. And it's done. Let's see what it did. And that looks like exactly what we asked for. Now, in retrospect, I think I should have made these tenons a little bit longer. And let's go ahead and just do that by hand this time. Tenon length, post tenon length. And let's set this to 5 inches. That looks much better. Let's do mortise and tenon joints between the posts, the 2 top beams. The tenons should not protrude through the beams, so make them 3 inches long. I think that's it. Now, the instructions on how to orient the tenons and the agent instructions are going to be a little bit weird. It's actually going to have them orient the tenons in the length of the beam, but since I think this is probably the one place where we want the tenon to be oriented in the other direction, right? So we want it to be longer in this axis and shorter in this axis. So let's go ahead and add that instruction. Make the tenons, let's do 1.5 wide in the beam length axis direction. So when we say length axis direction, the length runs sort of the length of the timber. So the length axis is in this direction. And then make it, so let's make it 4 inches long in the perpendicular axis. So different than how we normally fit with the longer dimension in the length axis of the mortise timber. And we'll let that go. And you might notice while the agent is going, this little refresh button will come up. You can press it, but it might error since the agent is in the middle of making changes. Let's see what happens. And it looks like it did add the tenons exactly as we described. So it looks like the agent is actually done, and it's currently just validating the changes for itself to make sure there weren't any errors. And in this case, there weren't any. So it looks like exactly what we want. And I just remembered we probably want some pegs to hold the legs to the feet. So let's go ahead and ask the agent to do that. Please add square pegs on the bottom joints. They should be 1.5 inches away from the joint shoulder, and they should be 1 inch square. So while that is going, let's actually make a couple changes by hand. Now, one of the things I wanted to do is to attach a vise to the side, and it's nice to have the post flush with the side of the tabletop when you add the vise. So I'm going to take this post here, and I can click on it, and you see this is the west-south post, and I'm going to change the dimension of it a little bit here. So we go into the code, we type in west, south, post. Ooh, make post. So what we will instead do is manually resize this post. So instead of using that make post function that the agent had made, I'll copy and paste it and put it here and replace center X with this, place center Y with that. West-south post should be that. And post size is the one that we should change. So you see here it is a 4x6. So we'll go ahead and change this to a 4x8. I think the agent is also done with adding the pegs. So let's go in here and refresh and see what happens. And as you can see, this got changed to a 4x8 now. And the agent has added pegs here. Now it does look like the pegs are maybe coming from the same side, and it would look nicer if they were coming from opposite sides. I could ask the agent to do this, and it should be able to figure it out. But let's take a quick look, and maybe we'll just do it by hand. Sometimes it's a little bit faster that way. So you see this cut mortise and tenon joint function takes post peg parameters. If we go here, they'll show the peg parameters. This is actually not what we want. So the direction that the peg enters is actually determined by this front face on butt timber. And it's asking to enter in on the right face. And you can see here, this is the right face that it's entering from. Then also here, this is the right face that it's entering from. But I like to have it so that the right faces on these feet sort of rotate around the footprint so that they're kind of pointing in opposite directions. So rather than have it change the entry face, I think I'm going to ask it to change the orientation or the direction of one of these feet to make the pegs enter from the other direction. And the reason you choose to do it that way is it enforces the symmetry of the structure a little bit better so that you have fewer edge cases, I suppose. It looks like the pegs are entering from the right face on both of the feet, and the right face is pointing the same direction on both feet. Can you change the orientation of the left foot so that its right face? I'm going to use some specific 3D math terminology here so that its local right face points in the global left direction. As you can see, this is the global up here, and this little widget here has the global directions. The font's a little small, but this says left. And right now the timber's local directions, which is these faces, that show up as we click on it align with the global ones, but they don't have to. So with this instruction, it should rotate one of the feet, hopefully, and not get anything else wrong. And the agent is reasonably good at 3D math. So if you know how to ask precisely for what you want, it's usually able to figure out the rest of it. So you might imagine if you rotated one of these feet, well, then the posts would kind of be in the wrong position and they would kind of crisscross on one side. But I trust the agent's going to be able to figure that out and adjust the positions of the posts on the foot that we're rotating once we rotate it. Okay, and it looks like it's done. Let's hit refresh and see what happens. So you can see it looks exactly the same, except the pegs are now entering from the other side. And what actually happened here is indeed now this outside face is the right face, and you can see it's pointing in the global left direction. So we were able to rotate this around. Let's move on. The next thing I want to do is add a stretcher that goes across the middle here. And the stretcher will be, let's say, a 2x12 piece of wood, and we're going to use the cross lap joint between the posts and the stretcher. Please join the two opposing pairs of posts with a 2x12 stretcher. The stretcher should stick past the ends of the post by 2 inches, and it should be joined to all 4 posts using a cross lap joint. Okay, and this looks like pretty much what we want. I think it looks pretty good. I'll be perfectly honest, I'm not really sure about this cross lap joint. I feel like the ends are probably going to blow out or something. Maybe we could have used some mortise and tenon joints here instead or something else, but I think this is fine. Lastly, cut an indent into the stretcher so it looks like a tray. It should have a 3/4 inch border around the sides of the stretcher and between the inside faces of the post. That is to say, the tray portion is only between the posts. The tray should be 1 inch deep. So there actually isn't really a joint that can be used directly to cut the tray for the stretcher. So I'm a little bit curious to see what the agent is going to do here. Kumiki is written in a very sort of open, extensible, straightforward way. So when the agent isn't able to find an existing joint to use to do what you want, it will start to get creative, and it may author its own joints, or it may do a couple other tricks to get the look that it wants. And it is going to have to think a little bit harder and read through the Kumiki code to understand what it can do. And it's done. This looks like exactly what I asked for. I am curious to see how the agent did this, so let's take a look at the code that it wrote. And it looks like it used one of the helper functions, chop profile on timber face, which will return a CSG object, which stands for constructive solid geometry. And those are kind of like the primitive operations used to build all the joints. And then it takes the output from this function and builds a joint out of it. So it basically created its own custom joint for this, which is to say a joint with only 1 timber in it, which is perfectly okay. And I guess we're basically done. I do think there are a couple small changes I would like to make. Maybe let's go ahead and do that. So I do think these legs don't need to stick out quite as much. The reason they are wider than the tabletop is to provide space for supporting these tenons. However, my original design used 4x6s, so we could actually make the tenons a little bit smaller and get the feet much closer. So I'm going to align the feet with the table. Now remember, these are 4x8s, and the gap between here is 1 inch, so this whole top is 17 inches. So let's go ahead and change the feet. Let's try 22 inches. Maybe 24 was better. All right, let's do 23. Maybe if I made the table a little bit shorter, it would be better and you could get away with smaller feet. Next up, I want to make the tabletop just a little bit longer, and I want the stretcher here to be a little bit longer because I do think this wood here is going to blow out. So let's look, top beam overhang. We'll make this overhang by 11 inches. And the stretcher stick out, let's make it stick out by 3.5 inches. And that's looking much better. I think I'm going to change the feet back to 24. And that's looking pretty good. Earlier when I was prompting the agent, I forgot to tell it to use actual lumber dimensions, so it's currently using nominal timber sizes. So let's go ahead and have the agent change everything to their true dimensions. Right now, all sizes of timbers are nominal. Please convert them to true dimensions. So basically a 4x6 is actually a 3.5 by 5.5. A 4x8 is a 3.5 by 7.5, and so on. And it's done. Let's see how it did. That looks pretty good to me. It even kept the gap between the tops correct. I think the one thing I would have done differently is to use a different joint between the stretcher and the post, but I'm also not sure what I really would have used there instead. So I'm happy to call this design done for now. If you like this, please like and subscribe, and stay tuned for the next video.